Good day, everyone. Today, we are going to be talking about heat energy. Heat energy is also called thermal energy. Heat energy is that energy that is transferred from a hot object to a cooler object as a result of their temperature difference. It is important to note that heat always flows from a hot object to a cooler object. Now, this is what we are talking about. Let's say we have a body A or an object A at a temperature of 30 degrees Celsius, and we have another object B at a temperature of 40 degrees Celsius. Now, if these two bodies come in contact, it is going to flow from one to the other. But what we are saying is that it always flows from a body at higher temperature to a body at lower temperature. So this is going to be the direction of its flow. So you can see the direction of the arrow telling us that its energy is actually flowing from B towards to A. Now, its energy, as other forms of energy, is measured in joules. So its energy is measured in joules. So that is the unit of measurement of heat energy. Now, the next thing we're going to be talking about now is what we call specific heat capacity. Specific heat capacity. Now, let's assume we want to heat 1 kilogram of water, and we want the temperature of that 1 kilogram of water to rise by 1 degree Celsius or 1 Kelvin. Now, we want to apply it to 1 kg of water, and we want the temperature of 1 kg of water to increase by 1 degree Celsius or 1 Kelvin. Now, you are going to need 4,200 joules of heat to increase the temperature of 1 kg of water to 1 Kelvin or 1 degree Celsius. Now, if you want to heat the same mass of aluminium, that is, you want to heat 1 kilogram of aluminium to 1 degree rise in temperature or 1 Kelvin, you are going to need just 900 joules of heat. Now, let me represent this on the board so that you are going to understand what I'm saying better. So, 4,200 joules of heat plus 1 kg of water to increase the temperature of water by 1 degree Celsius. Now, 900 joules of heat energy added to 1 kg of aluminium is going to increase the temperature of aluminium by 1 degree Celsius. That is, if you want to increase the temperature of 1 kg of water by 1 degree Celsius, the amount of heat energy you must add is 4,200 joules. Now, if you want to increase 1 kg, the temperature of 1 kg of aluminium by 1 degree Celsius, you need to add just 900 joules of heat. Now, scientifically speaking, the amount of heat energy that you need to add to 1 kilogram of water to change its temperature by 1 degree Celsius, that amount of heat is what we call specific heat capacity. Now, the specific you are seeing there is referring to 1 kg because we are interested in just 1 kg. So that is called specific heat capacity. So the specific heat capacity of water now is 4,200 joules per kilogram per degree Celsius or per kilogram per degree per Kelvin. Now, if you want to increase the temperature of aluminium, or if you want to increase the temperature of 1 kilogram of aluminium by 1 degree Celsius, you need to add just 900 joules of heat energy to it. Now, this is what we call the specific heat capacity of aluminium. That is, the specific heat capacity of aluminium is 900 joules per kilogram per Kelvin. Remember I said per kilogram means that you need to apply 900 joules of heat to 1 kilogram of aluminium to increase the temperature by 1 degree Celsius, or to increase the temperature by 1 Kelvin, whether it's a 1 degree Celsius or 1 Kelvin. Now, this is what we call specific heat capacity. So it is very clear now that each different materials have different specific heat capacity. Now, you can see that the specific heat capacity of water is almost 5 times. It's almost 5 times the specific heat capacity of aluminium. That is, the same mass of water is able to absorb more heat than the same mass of aluminium when they are heated through the same rise in temperature. And that is why water is used as coolant in motor. That is, in your car, water is used as coolant because it's able to absorb a large amount of heat and the temperature will not increase too much. But aluminium, on the other hand, can be used to make cooking pots because when it absorbs heat, it quickly gets hot, and when it is taken away from it, that is, when it's not being heated, it quickly gets cool. So what is the symbol for specific heat capacity? Now, the symbol of specific heat capacity will normally represent specific heat capacity using small letter C. And I'm going to write that now, and I'm going to write the unit of specific heat capacity so that whenever they give us, when we are trying to solve question later, and they give us a parameter, I think we should be able to identify, so that we're going to be able to identify that this parameter is actually specific heat capacity, even when they did not say this is specific heat capacity. So it is very important that you are able to understand something and you know the unit of that. So this is specific heat capacity. So we say specific heat capacity is represented by small letter C, and the unit of specific heat capacity, don't forget, is joule for 1 kg. That is why I said per kg per degree Celsius. You can say per degree Celsius, or if you like, you can say joule or joule per kg. Sorry, what I'm trying to change. Okay, you can say joule per kg per Kelvin. That is either you say joule per kg per degree Celsius or joule per kg per Kelvin. This temperature can actually be in Kelvin. That's what I'm saying. Or now, sometimes you're going to see them write the unit like this. It's just a matter of applying your mathematics, laws of indices. I can write this as this. I can say joules per kg. This is under, when it comes up, it becomes raised to power minus 1. That is law of indices. We are not teaching mathematics here, but that is, you can choose to write it like this. Then per degree Celsius also can be per degree Celsius like this, or per Kelvin you can say joule per kg per Kelvin. So that is how you write the unit of specific heat capacity. It is very important. Don't say, I don't need to, once I know the specific heat capacity is C, I don't need to know the unit. It is very important that you know the units. It is very, very important. And also, it is very important that you know at least the specific heat capacity. Different materials have different specific heat capacity. So that's, but you should be conversant with the specific heat capacity of water, because you're going to be using it, and sometimes you may need it and they may not give it to you. So you know the specific heat capacity of water is 4,200 joules per kg per Kelvin, or per kg per degree Celsius. Now, what if I ask you that, what do I mean by the statement that the specific heat capacity of a substance is 1,000 joule per kg per Kelvin. What do I mean by that statement? Now, this is the answer. The statement that the specific heat capacity of a substance is 1000 joule per kg per Kelvin means that the heat energy, the heat needed to raise the temperature of 1 kg of that substance through 1 degree Celsius is 1000. Now, or I can say the heat required to raise the temperature of a unit mass of that substance. When I say unit mass of that substance, it means that 1 kg of that substance. So I can say a unit mass or 1 kg, anyone. So the heat required to raise the temperature of just 1 kg or a unit mass of that substance by 1 degree Celsius is what we call specific heat capacity of that substance. So that is what the statement means. So don't forget I said that different substances have different specific heat capacity. So that is that for that. Now the next thing we're going to be talking about now is what we call thermal capacity or heat capacity. Remember specific heat capacity, but now we are saying heat capacity. We have removed the word specific. So now, assuming you want to heat 2 kilograms of water through 1 degree Celsius. Remember, it is still the same 1 degree Celsius. But now we want to heat 2 kilograms of water, not 1 kg like specific heat capacity. We want to heat 2 kg of water through 1 degree Celsius. Now, since I need 4200 joules of heat to raise the temperature of 1 kilogram of water through 1 degree Celsius. Now, if I need to raise the temperature of 2 kilograms of water through the same 1 degree Celsius, I will just say 2 times 4200, which is going to give me 8400 joule per Kelvin. Somebody is going to say, but you did not put per kilogram. Remember, we are not trying to heat 1 kg now, but the whole mass of the body. So that is why we are going to say heat capacity or thermal capacity is the quantity of heat required to raise the temperature of the whole body, of the whole mass of the body through 1 degree Celsius. Now, what is going to be the formula for heat capacity or thermal capacity? So that means we are going to say the mass of the body. Remember, the mass of the body times specific heat capacity is going to give us what? It's going to give us heat capacity or thermal capacity. So I'm going to write that on the board for easy understanding, and so that we can note down all of these things, because in the next few minutes we are going to be using this formula to solve questions. Please don't forget the specific heat capacity that we have talked about, and then we are going to be using that also. So here we are talking about heat capacity or thermal capacity. So I can decide to say heat capacity, you can decide to say thermal capacity. So here we say heat capacity. Now is equals to mass of the body times specific heat capacity. So that is how we find the what? The heat capacity or thermal capacity of a body. So that is the formula. So I can say, now I'm going to use a symbol to represent my heat capacity or thermal capacity. Remember, we use small letter C to represent specific heat capacity, but I'm going to be using C subscript P like this, capital letter C and subscript P to represent heat capacity. It's a matter of what you want to use to represent it. So, but just let them know that I'm using this to represent my heat capacity or thermal capacity. That is it. Just let them know that you're using this to represent your heat capacity. Remember, this is specific heat capacity. This is symbol, and this is heat capacity. Now, since this is the heat capacity, I can say, and I'm using this to represent this heat capacity, I can say C subscript P is equals to, which is my heat capacity or thermal capacity, is equals to mass times specific heat capacity, which is small letter C. So this formula is to be known and remembered, because you're going to be using it in a calculation later. Now, what is going to be the units? Remember, I always say, oh, what about the units? It is very important as as a science student to always remember, especially when you're doing physics, you need to know the unit of all the parameter you're given. So what is the unit of what? The unit of thermal capacity, or the unit of heat capacity? Well, I can just tell you that the unit of heat capacity is joule per Kelvin, or joule per degree Celsius. And I'd already explained why we don't have what? We don't have per kg as heat capacity, specific heat capacity, because specific heat capacity deals with just 1 kg, but this one deals with the whole mass of the body. But if you are to even determine, the unit of heat capacity through this formula, we can do that. Mass is kg times, and we know that the unit of specific heat capacity is joule per kg per degree Celsius. So we can say times joule per means over kg per degree Celsius, like this. So this kg we cancel kg, and we can say joule per degree Celsius. So that is the unit of what? Thermal capacity or heat capacity. Now, remember, you can write this as joule per what? Kelvin. So anyone you like. And you can rewrite this using the law of indices. You can say joule then per degree Celsius, like this, or joule per Kelvin, like this. Do you understand? So that is the unit of specific heat capacity, or thermal what? Capacity. So